Welcome to all of you in Sankalpa Education Pratham classes. I am Sachin Patil, delivered lecture on rotational motion. Right now we are going with the next point is a conical pendulum. In conical pendulum, first of all, we have to think about the pendulum. What is the pendulum? A tiny mass connected to long inextensible means what? There will be no any extension. When we attach a lot of mass to that string, at that time there will be no any extension or elongation in the string. At that time it is called as inextensible, massless. That means the string which does not have any type of mass. But on universe there will be no any substance which doesn't have any mass. Therefore each and everything which is very light, like a needle, small needle, as well as any element, that means electron, proton, all matter which is exist in universe has a small mass. But here we have to think about the pendulum is an ideal pendulum, and therefore it is a massless pendulum and flexible string suspended to rigid support. At that time we get the pendulum. When pendulum is oscillated in a single plane, at that time it gives the simple pendulum, or it is called as a simple pendulum. When oscillate in single vertical plane, we get simple pendulum. What does it mean? First of all, when we think about the pendulum, what is pendulum? It is nothing but a point mass. This is a point mass or tiny. It is also called as a bob. Bob is here, and this bob is attached to long inextensible string, and which is suspended from the rigid support. At that time when it is oscillated in a single vertical plane, at that time you will get the oscillations, and at that time this pendulum is called as a simple pendulum. Right now we are think about the conical pendulum. It is nothing but it is a different type of pendulum in which if string of pendulum describe right circular cone and bob, that is a point tiny mass or object is here. Object describes horizontal circular motion, then it is called conical pendulum. What does it mean? First of all, we have to think about the definition of that conical pendulum, and inside the conical pendulum, what is the consideration like that one. Inside conical pendulum, first of all, bob or a small tiny mass which describes the horizontal circular motion with one center is there. Let us consider with the center of that horizontal circle which is described by the bob, and at that time the string attached to the rigid support which describes the circular cone is here, and this cone is like that one, and this cone is described here with Bob describing the horizontal circle with the radius r is here, and C with the center of that circle. Let us consider suspension point of that is point A, where the simple pendulum is attached, and C be the center of that one, and Bob B is at a position B. At the time, once again we think about the definition of that conical pendulum. Inside this string of pendulum described the right circular cone. That means string described the cone is here. It is a ice cream cone like, and it is inverted here, and mass or object will describe the horizontal circle is here. At that time, R be the radius of that horizontal circle, and you will get the A be the suspension point of that particular pendulum. At that time, here Bob has two types of forces acting on that one. One is a tension which is acting towards the center suspension point T0. Let us consider T0 be the tension in the string which is acting towards the suspension point A, and which is resolved into two components. First component along the radius of the circle and toward the center, and it is nothing but a T0 sine theta, and one component which is vertically upward is there, and which is nothing but a T0 cos theta, which balances the weight mg of that bob. It is found in a inertial frame of references. In inertial frame of reference, and it is first of all we have to think about the bob. It is acting towards the center, and the centripetal force is provided by that T sine theta, and T cos theta is another component of that T0, and which is acting vertically upward, and which balances the weight of that bob. That means mg. And in non-inertial frame, you will get something different in that one, and which is nothing but like that one. Once again, you have to take the consideration of Bob gives the horizontal circle which is suspended at point A. Once again is here, rigid support is here, and this point is nothing but A point is here, and from A point you will get the string provides a right circular cone is here, and this is radius of that circular path. And in non-inertial frame, centrifugal force is acting away from the center. T0 sine theta, which is acting toward the center C, and T0 with the tension in the string which is acting along the string toward the suspension point, and here T cos theta is acting vertically upward, and which balances the weight mg of that bob, and m or omega square be the balancing centrifugal force which is acting away from the center. It is found in the non-inertial frame of references. Once again, we think about the definition of the conical pendulum. Inside the definition of conical pendulum, string provides a string of pendulum gives or describes the right circular cone. That means this like that one, right circular cone, and Bob described the horizontal circular motion, inside which you will get the conical pendulum is here. And in conical pendulum there will be two forces acting. There have two forces acting on that conical pendulum. One is a T0 which is acting towards the suspension point along the string of that pendulum, and second one is a weight mg, which is acting downward direction, and t0 is resolved into two components. First is a t cos theta and t sin theta, which is given in the following description. First of all, we have to think about the what are the most important things related to that one. First of all, m is the mass of bob, capital L be the length of pendulum, and forces acting on that, bob are, first force is weight mg, downward, and second is a t0, that means tension in the string, If theta be the, let us consider theta is here. One thing is remain here is a theta. Theta is a vertical. It is an angle made by string with a vertical. It is a semi-vertical angle. What does it mean? First of all, we have to think about the theta is here, and then we have to discuss next things related to that one. Theta is a semi-vertical angle which is made by that string with a vertical plane or vertical axis is there, and this is the theta. Once again I am explained that it is a half angle made by that string with a vertical, and it is nothing but theta, and this theta is nothing but a semi-vertical angle is here, semi-vertical angle. Right now we are going with the considerations of that t0, that means tension in the string, t0 resolve into two components. One is a t0 sin theta acting toward the center, t0 sin theta horizontally acting towards center and gives resultant force as centripetal force, and therefore we will get the consideration of that one, and that much is related to that consideration of t0 sin theta. It is equal to m r omega square is equal to m v square divided by r also, and this is the equation 1 is here. Once again we know that I am explained that consideration is t0 is resolved into two components. One is a t cos theta and t sin theta. T cos theta balances the weight of that bob, and t sin theta it is acting toward the center, and which balance is the resultant centripetal force which is acting on that particular bob, and therefore we will get the m be the mass of the bob, L be the length of pendulum, force acting on the bob are two forces are there, weight mg downward direction, tension in the string t0, and theta is a semi-vertical angle which is made by the string with a vertical, and this is the theta is a semi-vertical angle. By using the consideration of this one, we will get the t0 is resolved into two components. One is a t sin theta which is horizontally acting towards the center and gives the resultant force on the resultant force as a centripetal force, and therefore you will get the T0 sine theta is equal to mr omega square is equal to mv square divided by r is here. Right now another one consideration is related to that conical pendulum is nothing but first of all we have to think about the next one is T0. Second component is a T0 cos theta, which is vertically upward and balances weight of bob, and therefore you will get the T0 cos theta, it is equal to mg, and this is your second equation is here. And from these two equations we will get the consideration of omega also, and this is given as a consideration like that one, omega 0 from equation 1 and 2. From equation 1 and 2 we know that the equation 1 is T0 sine theta, it is equal to m r omega square, or it is also m v square divided by r. This is equation 1 is in back consideration, and right now we will get the T0 cos theta is equal to mg is the second equation. From these two equations from 1 and 2, once again I am going with that consideration, we get omega 0 is equal to omega square is equal to here, omega square is equal to nothing but we will get the consideration of these two is g sine theta divided by r cos theta. R cos theta is here, g sine theta, r cos theta is here, but from figure we know that, once again I am repeating that the from equation 1 and 2 we will get the omega square is equal to g sine theta divided by r cos theta, and this is done by using dividing equation 1 by equation 2, and you will get the transformation of that considerations like that one. Let us consider dividing equation 2 by dividing equation 1 by dividing equation 2, you will get the consideration of T0 sine theta divided by T0 cos theta is here, and you will get the m r omega square, that means this one, and divided by mg is here. M is cancelled out, and G and R transferred here. T0 also cancelled here. G is dividing here. It will get the multiply, and therefore G is here. And R is multiply here. You will get the divide here, and therefore omega square is equal to G sine theta. G sine theta divided by R cos theta is here. Right now from figure you will get the from figure what you can say. First of all we have to think about the from figure sine theta is here. I am now going with the figure diagrammatical representation of that conical pendulum. First of all we have to think the theta is here, that means a semi-vertical angle, and the length of pendulum is a L. Length of pendulum is a L, no doubt about that one. This is the length of pendulum, it is nothing but a capital L, which is given in the consideration. And here you will get the sine theta. Sine theta means opposite side divided by hypotenuse is here. And from this figure sine theta, that means this is the theta in triangle ACB. Once again I am thinking about the triangle ACB. C is 90 degree, and therefore this theta is here, and this is the hypotenuse is here, and therefore opposite side divided by hypotenuse. Opposite side is nothing but a BC, and it is nothing but T0 sine theta. BC is nothing but a radius of that horizontal circle, and it is nothing but R is the radius of that circle, and therefore this is R, and therefore sine theta sine theta, it is equal to r divided by capital L, that means the hypotenuse is nothing but and this L is transferred, you will get the L sine theta. Once again I am repeating here that this triangle is considered ACB is a triangle ACB. Inside the triangle ACB, BC is the side, this is the radius of that horizontal circle, and therefore it is considered as R, and L with the length of that conical pendulum, it is taken here, and sine theta of that one is nothing but opposite side, that means BC is nothing but a small r, that is the radius of that horizontal circle, and L with the hypotenuse of that triangle, and therefore sine theta is equal to r divided by L, and r is equal to L sine theta. And by putting those value inside the consideration of this omega is nothing but omega square, you will get the omega square, and therefore we will calculate the omega from that one. And first of all we have to think about the omega square is equal, therefore from figure you will get the small r is equal to L sine theta, small r is equal to L sine theta. Putting those value inside the omega square is equal to G sine theta divided by r. We have to put the value of r is here, and r is nothing but L sine theta into cos theta. Now sine theta is cancelled to sine theta, and you will get the G divided by capital L into cos theta. This is the value of omega square. From this you will get the omega is equal to, taking square root on both sides, you will get the G divided by L cos theta, G divided by L cos theta. And we know that omega is equal to 2 pi divided by t is here, and therefore from this equation you will get the t is equal to 2 pi divided by omega. But the value of omega is nothing but a square root of G divided by L sine theta, which is putting inside the denominator, and it is nothing but a L cos theta divided by G, because it is a nothing but a reciprocal of that one divided by omega is nothing but a reciprocal of that omega, and reciprocal of that omega is nothing but a square root of L cos theta divided by G is here, and therefore t is equal to, and therefore you will get the t is equal to 2 pi into square root of L cos theta divided by G. This is your equation related to time period of the conical pendulum. Similarly, you will get the frequency. Frequency is nothing but a reciprocal of time period, and therefore frequency is denoted by n is equal to 1 divided by t. That means it is a reciprocal of that value, and it is nothing but a 1 divided by 2 pi square root of G divided by L cos theta, G divided by L cos theta. And this is the value of frequency of frequency. First of all, we have to get the consideration from the equation t cos theta is equal to mg and t sin theta is equal to mr omega square. From this equation you will get the omega square, and from figure you will get the consideration of, from figure means what, we will get the figure is here, and from figure at triangle ACB, inside which sin theta is equal to r divided by L, and r is equal to L sin theta, and sin theta is equal to r divided by L, and r is equal to L sin theta. From this you will get the r sin theta, r is equal to L sin theta, r is equal to L sin theta. Putting inside the equation omega square, you will get the omega square is equal to G divided by L cos theta, and by using omega square is equal to G divided by L cos theta, therefore omega is equal to square root of G divided by L cos theta, and you will get the time period is nothing but time period is equal to 2 pi divided by omega, and you will get the t is equal to 2 pi square root of L cos theta divided by G, and frequency is nothing but a reciprocal of time period, and from this you will get the n is equal to 1 divided by t, and which is nothing but a 1 divided by 2 pi inside the square root of, inside the square root you will get the g divided by L cos theta. And right now you will get the considerations of this conical pendulum. First of all, if you will get the considerations of, we know that the time period t is equal to 2 pi inside the square root of so time period is equal to L cos theta divided by g, and frequency n is equal to 1 divided by t, it is equal to 1 divided by 2 pi square root of g divided by L cos theta, g divided by L cos theta. From this you will get the considerations of, first one thing is, if L and g are constants, then period and frequency depends on theta only. If L and G are constant, then theta is changes, then you will get the T changes. Here also theta is changes, then you will get the N is frequency also changes. Second one is during revolution, string never becomes horizontal. If during this revolution, when string becomes horizontal, at that time vertical component of that tension in the string, that means vertical component is nothing but T0 cos theta, and if theta becomes 0, theta becomes 90 degree at that time, this component becomes 0. This component becomes 0, because here we know that about the consideration of in conical pendulum. First of all, we have to think considerations of that one. Here semi-vertical angle is theta. When this string is moving in this way and it becomes a horizontal is here, at that time it becomes a horizontal circular motion. It is not a conical pendulum. At the time this horizontal circular motion, theta is equal to 90 degree, and theta is equal to 90 degree, at that time cos theta is equal to 0, and this vertical component which is acting on the pendulum T0 cos theta, it becomes 0, and this component becomes 0. And when this component becomes 0, that means you will get the theta is equal to 90 degree. mg is not balanced at that time, because mg is balanced by that T0 cos theta, and mg is not balanced at that time. Frequency becomes infinity, because we know that the frequency, equation of frequency is here, and this frequency becomes infinity because theta is equal to 0. Then this denominator becomes 0, and denominator becomes 0, then this division becomes infinity. Frequency becomes infinity, period becomes 0. Because the period is depends on that L cos theta, and theta is equal to 90 degree, that means this value is 0, and 0 divided by g is 0, and square root of 0 is 0, 0 into 2 pi is equal to 0. Therefore time period is equal to 0, which is not possible, because if any particle is moving and it completes some distance or travels some distance, at that time it completed some it required some time, and therefore it is not possible. And T0 tension in the string is nothing but mg divided by cos theta. From equation 2 is here, mg divided by cos theta. T0 is equal to mg divided by cos theta from equation 2. This is from equation 2. Equation 2 is nothing but what we know about the t cos theta is equal to mg, and this becomes 0 because of the cos theta. Theta is equal to 90 degree, and therefore t cos theta is equal to 0, and during this frequency is equal to infinity and period is equal to 0, which is not possible, and t0 is equal to mg cos theta, as well as kinetic energy, that means 1/2 m r square omega square. It becomes infinity. Both t0, it in this also becomes infinity, and kinetic energy is also becomes infinity, and it is not possible. And due to this, during the revolution, string never becomes horizontal, and when string becomes horizontal, at that time you will get the different things which is not balanced, the conical pendulum, and due to that you will get the change of that conical pendulum motion is a circular motion, and therefore which is not a particular case related to that circular motion. This conical pendulum is a particular case of that circular motion, in which bob gives the horizontal circle and string gives the right circular cone related to that horizontal circle, and at that time this t0 tension in the string divided into two components. One is a t cos theta, and t0 sin theta is which is acting towards the center of circle, and this is related to that conical pendulum. It is a thorough relation, thoroughly giving the complete knowledge about the conical pendulum. If you like this, then subscribe my channel and like it. Thank you.